So good evening to all of you. Is the video and audio clear to everyone? Thank you. So let us begin our today's session on uniform continuity. So after the completion of the discussion over this concept, the chapter of continuity will be completed. So from next session onwards, we are going to discuss about derivability, or you can say the differentiability of a function. So that is our next topic, which we discuss in the next session, right? So coming to uniform continuity, here our objective is nothing but we are going to find for a given epsilon, we are just finding a unique delta. So that in the domain of F, whenever you take 2 points, say x1 and x2, such that the difference between them is less than delta, then modulus of f of x1 minus f of x2 will be less than epsilon. So this is the concept of uniform continuity. So in the domain of F, we are selecting any 2 points such that the difference between them is less than delta, then trivially or automatically the difference between f of x1 and f of x2 will be less than epsilon. That is the concept of uniform continuity, right? Now let us do some of the problems on this. So please take the first one. Is the concept clear, or you need any elaboration on this? Yes or no? Right. So this is the problem. If you take the function f of x is equal to x cube on closure interval minus 2 comma 2. So you take the function f of x is equal to x cube on closure interval minus 2 comma 2, and I am going to prove that it is uniformly continuous. It is my task. In other words, I am going to build a relation between epsilon and delta satisfying the condition. So first of all, you take x1 and x2 in the interval minus 2 comma 2. So as per observing its value, I can say that mod x1 is less than or equal to 2 and mod x2 is less than or equal to 2. Accepted? Yes or no? Right. Now I am going to take the 2 points such that mod x1 minus x2 is less than delta. You take. All I am going to do is I am going to build a relation between epsilon and delta. That is my overall view. Now you consider modulus of f of x1 minus f of x2. So do you agree for this point or not? Yes. Right. Now if you substitute the values there, it will be modulus of x1 cube minus x2 cube, applying the functional values. Since it is of the form a cube minus b cube, I am going to write it as modulus of x1 minus x2 into x1 square plus x2 square plus x1 x2. Can I write like that? Right. So it will be written as mod x1 minus x2 and here modulus of this one. Again, this value will be less than or equal to modulus of x1 minus x2 into mod x1 square plus mod x2 square plus mod x1 into mod x2. So expanding the modulus there. So if you substitute the corresponding values there, it is equals to mod x1 minus x2 into, this will be 4 plus 4 plus 2 into 2. Accepted? Fine. How I have taken these values from this point? You can take less than or equal to here. Any more queries over this? Yes or no? Are you getting it or any doubts? Are you clear? Or any questions for you? Then it will be different. Then it will be different. Since the same values are different, it is different. So in that case, you can define like this. Suppose if you take the interval minus 1 comma 4. Why minus 1 comma 4? You take any arbitrary interval a comma b. Is that accepted? Right? So in that case, we can say that whenever you take 2 points x1 and x2 in this closed interval, then since you are taking the two values, the values may be either positive or negative. If you consider modulus of x1 and modulus of x2, both values will be positive. So you can take the big among them. Then what happens if you give a name for this? It is equal to k. Then this value will be less than or equal to k square and k, like that. Will you agree? Are you getting the logic? Right. So in that way we define like this. On the whole thing, we are just giving a relation for epsilon and delta, that's all. For the given interval, I have defined the simplification like this. Fine. So is that point clear for you? If the interval is taken in such a manner? Because I am going to do a similar kind of problem on that. So in case of minus 1 comma 4, 4 is maximum. There is no need to take the last value as maximum. Since if you take, say, one point is 0.1, another point is 1.5. Among the two, 1.5 is the maximum, right? If you consider the maximum, so in that case, 1.5 square plus 1.5 square plus 1.5 into 1.5 you will take. That is also acceptable. The underlying idea is you are just building a relation between delta and epsilon, that's all. If delta is chosen like this, what could be the possibility of epsilon? And epsilon and delta are unique, that's all. If not a closed interval, that is a different issue. We will discuss the problems on this also. Right. So is this part clear? Fine. Now what happens? I have calculated this value, this is 12. So modulus of f of x1 minus f of x2 is less than or equal to mod x1 minus x2 into 12. So since so far I have a fixed delta, I didn't choose epsilon. So choose epsilon greater than 0 such that this value is less than epsilon. So that is mod x1 minus x2 into 12 is less than epsilon. So mod x1 minus x2 is less than epsilon by 12. Is that clear? Right. Now if you compare the two values, so what is the relation between delta and epsilon? Delta is equal to epsilon by 12. Accepted. So what does it mean? If you take epsilon is equal to 1, delta is equal to 1 by 12. If you take epsilon is equal to 1 by 2, delta is equal to 1 by 24. Are you getting? That is the overall idea here. So we are building a single relation. For a given epsilon, this will be the given delta. Or for a given delta, this could be the epsilon value. That's it. Any more questions for the approach or procedure to anyone? Or is that clear? Because we have chosen that this value is less than epsilon means this value is less than epsilon. I am comparing the inequalities. I got two inequalities. I got one inequality that mod x1 minus x2 is less than delta. I got another inequality that mod x1 minus x2 is less than epsilon by 12. Actually, the original inequality is mod x1 minus x2 into 12 is less than epsilon. Epsilon is chosen in such a way. So from this, to compare delta or to draw a relation between delta and epsilon, I have reduced this value as epsilon by 12. So that both inequalities, LHS is same, so RHS could be the same. That is the idea. Clear? Right. So can I erase this? Fine. Actually, there is one interesting result that if you take uniformly continuous function, it may be open interval, closed interval, or any set you take. If the function is uniformly continuous, then it is continuous. But the opposite is not true. For this, we take some counter examples. So if f is a continuous function on a set, then f need not be uniformly continuous on that set. For this, we take some relevant examples. Also, the interesting result is it will be if and only if f from closed AB to R is continuous. So the function what you have taken is a continuous function and defined on the closed interval. Then if you say that it is continuous on the closed interval, every continuous function will become uniformly continuous. There is a result. So based on this result, whenever a closed interval is given to you, if you have proved that the function is continuous on this interval, immediately you can say that it is uniformly continuous on that interval. There is no need to prove separated delta and epsilon value, because I am just going to the proof of the theorem. In this, our main idea is nothing but to build a connection between epsilon and delta. So in the theorem, to describe or to find how the delta will be, a procedure is given. It is nothing but whenever you have a closed interval, you can take a partition on it. I think you know what is meant by a partition. Do you? Yes or no? So very simple. Suppose we have a closed interval 1, 4. I am choosing arbitrarily some of the points between 1 and 4. That is user defined. You can take any numbers. Say 1, 1.5, 2.2, 3, 4. This is a partition. You can take any number of points between the starting point and the ending point. So it is nothing but if you have the number line like this, you are arbitrarily selecting some of the points here. So for each point you have an interval. We call it as subinterval. In other words, you are considering it as segment by segment. So for each interval, you can have the length. So what is meant by a partition? Whenever you have a closed interval, you can choose arbitrarily some of the points between the starting and the ending. That is called the partition. Is that clear? What is meant by a partition? Partition will be chosen in so many different ways. There are infinite number of ways to choose a partition. Partition is not fixed. You can take all equal values as 1, 2, 3, 4, 1, 1.5, 2, 2.5, 3, 3.5, 4. In different manners, you can choose a partition. So partition is not fixed. So whatever the partition you consider, you will have some segments. So here 1 to 1.5, a segment. 1.5 to 2.2, a segment. 2.2 to 3, a segment. 3 to 4, a segment. So here you have one subinterval, another subinterval like this. So for each subinterval, the length is there. So what is the length here? The difference between these two. Here the length is 0.5. Here the length is 0.7. Here the length is 0.8. Here the length is 1. Okay. So length is nothing but difference between endpoints of the subinterval. What are the subinterval you choose? Now, among all the lengths, what is the smallest one? 0.5. Now, the delta is defined as half into minimum of the smallest subinterval lengths. If you say delta 1 is first interval length, delta 2 second subinterval length, like so on. If you have taken n subintervals, for each subinterval you calculate the length, take the smallest length and make it half. That is taken as delta. I will write here. Suppose you have n subintervals. For each subinterval, you have the length. For the first subinterval, delta 1 is the length. For the second subinterval, delta 2 is the length, and so on. So for n subintervals, you will have n lengths. Among all, you take the smallest one, minimum. So here you have 4 subintervals, 0.5, 0.7, 0.8, 1. These are the lengths, among which the smallest is 0.5. I am making it as half. So 0.25 is my delta value. So if I choose delta, then obviously for given epsilon, this is the way of choosing delta, so that always the function will become uniformly continuous. This is the theoretical procedure for choosing a delta and a closed interval. It was defined in that. Okay? Are you clear? Yes or no? Right. So the main perspective here is, whenever you have a function defined on the closure interval which is continuous, then obviously it is uniformly continuous. You should underline this point. So on a closure interval, continuity, uniform continuity, both are equivalent. So for the other sets, it is different. If a function is uniformly continuous, then it will become continuous. Continuous need not imply uniform continuous, right? For that, we will take some of the problems before doing some problems on uniform continuity. So let us take the other one. Suppose the function is defined like this. Suppose it is taken closure interval 0, 2. I have taken the function as f of x is equal to x by x plus 1. I am going to prove that the function is uniformly continuous on this. Sorry. In other words, I am going to build a relation between delta and epsilon. So you take any 2 points, say one point x, another point y, belong to the closure interval 0, 2, such that mod x minus y is less than delta. Now you consider mod f of x minus f of y. So if you substitute the values, it is nothing but x by x plus 1 minus y by y plus 1. So if you go for LCM, x plus 1 into y plus 1, and it will be y minus x. I hope so. Am I correct here in getting the LCM? Please check in the numerator. X minus y, right? Since the modulus is there, you can treat it as now I am going to say that this value will be less than or equal to mod x minus y. Why? Because since you have taken that x comma y belongs to the closed interval, x is greater than or equal to 0, y is greater than or equal to 0. So if you consider x plus 1 will be greater than or equal to 1, y plus 1 will be greater than or equal to 1, and hence 1 by x plus 1 is less than or equal to 1, 1 by y plus 1 is less than or equal to 1. So if you consider the product is also less than or equal to 1. So I can write like this. Therefore, choose epsilon here such that this value is less than epsilon. So what happens? If you compare the two inequalities, I got one inequality as mod x minus y is less than delta while choosing the numbers. Another one is I have chosen epsilon like this. So if you compare these two, delta is equal to epsilon for this problem. So if you choose delta is equal to epsilon, then the function will be uniformly continuous on this closed interval 0, 2. You can ask one more question that can't we do in the other way? Yes, we can do. If you prove that the function x by x plus 1 is continuous on the given interval, since every continuous function is uniformly continuous on the closed interval, it becomes uniformly continuous automatically. there is no need to build a relation here. But first you need to prove that x by x plus 1 is continuous, right? So how to prove that x by x plus 1 is continuous on the given closed interval? Any guesses? Say. Are you getting the point what I am saying? Yes or no? It is justly simply writing like this. I will make space here. You can take maximum of 0, 2. Actually, the underlined idea here is, if you take the maximum of 0, 2, it will be the value of 2. Accepted? Right. But actually, epsilon usually at most 1. You cannot take more than 1, isn't it? So, if you take maximum 2, so you are saying that x minus y, what is the maximum possibility for x and y? That is also an issue. 2. So that means that in this case, if you prove that delta is equal to epsilon, then epsilon will be 2. If you think like that. So practically that we won't accept. The underlined idea here is very simple. In the domain, you are taking any 2 points randomly whose gap is less than delta. So with regard to delta, what is the corresponding gap between the values? That could be epsilon. That's it. So delta usually not a huge value. So we are taking a small neighborhood around them. That's why usually we don't do like that. Because obviously, whenever you take a closed interval, always the last point is nothing but the maximum value. So you are taking the maximum gap for them. So which practically not correct. Fine. Is it okay? The solution part to all? Yes or no? Fine. Now I am going to say that the function is continuous on the given closed interval because the function is defined as x by x plus 1. It is a rational function and hence continuous, and it will not be undefined on the given interval, because let me say if the value is undefined, say denominator is equal to 0, then what is the possibility of x here? X is equal to minus 1. Is the point 1 minus 1 belong to the interval 0 to? No. Therefore, the function value always exists. It is a rational function. Hence, it is continuous on the given interval 0, 2. So, the function is continuous on the given closed interval. Hence, it becomes uniformly continuous. So, in 2 lines, you can write like that. But if you want to build a traditional relation, we will do like this. Is that okay? The explanation part? Right. So let us take the other problem. So if you take that f of x is equal to x square, then it is uniformly continuous on every closed interval of R, but not uniformly continuous on R. That's why simply I am writing that since it is a rational function, it is always continuous. Every rational function is always continuous for every real number. It is true. Actually, let me say, we have a small formula in intermediate, I hope so. Inverse functions, logarithm functions, arithmetic functions, trigonometric functions, and exponential functions. So we know that they are continuous. If the function is different, then the procedure is not as usual. So always we go with the definition. That's why for majority of the problems, we are building a connection between delta and epsilon. That's it. In closed interval, you are simply describing the nature of the function. It is enough that if you are able to say that the function does not vanish and gives a finite value, that is enough to show that it is continuous. Because continuity is nothing but if you draw the graph of the function, you are getting the graph in a continuous manner without having any cuts, isn't it? In other words, at every point in the interval, you are going to get the corresponding function values. That if you are able to present it by depicting the nature of the function, that is sufficient to show that it is continuous. Fine. There is the other manner. If you are able to, if the function is bifurcated in a manner, here it is not a bifurcated, it is a straightaway function. Whenever a closed interval is there, I have proved that if you want to say that the function is continuous on the interval, you should prove that at A it is right continuous, at B it is left continuous, and for any intermediate point between A and B it is continuous. So that we can say that the function is continuous on the whole interval. So if we are able to prove that by calculating the limits, that is okay. Otherwise, by simply depicting the nature of the function by saying that the function value does not vanish over that interval, then it becomes continuous. That's it. Or if we are good at building the relation between delta and epsilon, always we follow that procedure. We will build a connection between delta and epsilon always. Okay? Is the strategy clear or not? Right. Same question in 2,4 interval. So f of x is equal to x square is uniformly continuous on closed interval 2,4. Delta is equal to epsilon by 8 you have chosen. Right. So let us take the problem first. In the problem solution itself, you are going to get the respective delta and epsilon values. That is applicable for everything. Now what it is given, if you take any closed interval for R, then it is uniformly continuous. If you take the whole system R at once, it is not uniformly continuous. That is the objective, isn't it? Right. Now let us take any closed interval in R. And as and when you are saying about an interval, the first value is less than the second value. Accepted? 2,4, 3,5, etc., etc. So always we have A is less than B. Now in this, let us take any 2 points such that the difference is less than delta. All I want to do is nothing but I just have to bring a connection between delta and epsilon. So you are taking any 2 points in the interval whose gap is less than delta. Delta is a fixed number. Delta is known to me. I can take delta is equal to 1 by 2, 1 by 3, anything. So if I take delta is equal to 1 by 2, what is the possible case of epsilon you are defining? Right. So for this, let us consider f of x1 minus f of x2. Modulus. So this is equal to mod x1 square minus x2 square. This is equal to modulus of x1 minus x2 into x1 plus x2. Then you can write it as mod x1 minus x2 less than or equal to mod x1 plus mod x2. Accepted all? The bifurcation of that equation. Now what happens? You don't know. You can take any closed interval AB, and x1 comma x2 are any 2 points in that interval. You can take any 2 points in that interval AB. One may be positive, one may be negative. Any interval you are taking. Now what happens? Whatever the real numbers you take, usually one will be big, one will be small. So you are going to take that k is equal to maximum of modulus of x1 comma modulus of x2. This ideology I have already discussed it, as one of our friends asked a question. So among the two modulus values, you take the big one, that is k. So here you can say that it is less than or equal to mod x1 minus x2 into k plus k 2k. Accepted? How the value is taken? So at this point you choose epsilon. So choose epsilon greater than 0 such that 2k into mod x1 minus x2 is less than epsilon. You choose epsilon like this, because this value is less than or equal to this, and at this point you are choosing epsilon. So to draw a connection between delta and epsilon, so this implies that mod x1 minus x2 is less than epsilon by 2k. So observing these two values, I say that delta is equal to epsilon by 2k. So by choosing delta is equal to epsilon by 2k, the given function is uniformly continuous on any closed subinterval of R. Fine. Is that clear to you? So please check on the procedure, what we have done. Any more questions over the approach in getting the relation between these two? Yes, at 2 comma 4, k is equal to 4. That is correct. So if you take one value is 1, another value is 1.5, k is equal to 1.5. Accepted. That is the ideology. Any more queries? So please take a note of it. Then we are going to do the second part of this. So what is the problem saying? If you take the whole number line R, you can take any closure subinterval. On this, the function is uniformly continuous. But if you take the number line itself as the interval, then it is not uniformly continuous. So what is our meaning? That in the whole real number line, I am taking 2 points whose value is less than delta. Then the corresponding difference between the images need not be less than epsilon. That I should do by means of an example. Okay. So for each case delta is different means, please understand here, how can you say delta is always chosen as epsilon by 2k, right? So you are building the relation between delta and epsilon. Now you can practically verify whether that relation holds or not. You can take a counter example. You can take a counter example. Is it possible to take a counter example here? So you are saying that different, yes, if k is equal to 2, delta is equal to epsilon by 4, fine. Delta is equal to epsilon by 4, very nice. So epsilon is nothing but 4 delta, you can say. Yes. Right. So here my question is, you take a subinterval here, take any two values in that whose gap is less than delta, that you fix, and verify whether the corresponding relation is less than epsilon or not. So if we straight away say that apart from taking maximum of these two values, I always choose the last point as the maximum thing, then it is okay. But we are choosing here delta as small as possible. Right. Yes. Delta is small when we choose last point in this case. However, let me finish the problem. For the other part, what you are saying, for the whole real line R, you choose any 2 points such that whose gap is less than delta. I am not taking any subinterval. I am taking the whole real number line, and in this I am taking any 2 points whose value is less than delta. And I am saying that if you consider f of x1 minus f of x2, that need not be less than epsilon. It is always not possible. If it is possible, then it is okay. So mod x1 minus x2 into mod x1 plus into is less than or equal to mod x1 minus x2. How can you write like that? It is always true. Is that true? You are asking for this, right? Is that your question? How it will be? Unless knowing about these two, if they are one, it is okay. If they are one, that is okay. That's why this summation could be at most 1. In the other sense means you are choosing very small delta here. It will be true like this. This is the correct approach, right? Because you are taking any 2 points, right? So for the 2 points, I am taking the biggest one, because obviously it is a positive number. It is a positive number. Among the two things, you are taking the big one. Suppose this is 1 and this is 2. Big one is 2. This is 2 plus 2 less than or equal to. In this way, I have given the argument like that. So at that point, you choose epsilon. Okay? Fine. So let me continue with the other solution part. So this thing I am going to prove. Even though I have chosen two numbers whose gap is less than delta, the difference between the function values need not be less than epsilon. How it will be true? So let us take that epsilon is equal to 1 by 2. You fix any delta. You take any delta greater than 0, that is your choice. Now, if I take, so whatever the delta you take, usually you can find a positive integer such that 1 by n is less than delta. Accepted? Yes or no? Do you agree for it or not? For suppose you have a doubt, let us say delta is equal to 1 by 2. Can you find a positive number n such that 1 by n is less than delta? Suppose if you take delta is equal to 1 by 4, can you find a positive integer n such that 1 by n is less than 1 by 4? Is it possible? Yes or no? Are you getting the idea? You agree or not? Right. So you take any delta, then it is possible there exists a positive integer such that 1 by n is less than delta. So what is my intention to show? I am taking two numbers whose gap is less than delta. If I consider function values, it will be less than epsilon. So I am taking that you can take one value as you can take it as since you are taking it as, you can do the other way around also. If you take if you consider in this way also you can choose. If you are confusing about this what is 1 by n etc etc, if you are confusing like that, in this way also you can choose. So you forget about this n belongs to z plus concept, you will get confused. So what is my intention? I am taking just two numbers whose difference is less than delta. If we calculate the function values, the difference need not be less than epsilon. So let us check that x1 is equal to x1 and x2 is equal to x1 plus delta by 2. The difference will be less than delta. Now let us calculate the function values. So if we calculate f of x1 minus f of x2. So let us substitute the values there. So I have changed that one value is x1, another value is x1 plus delta by 2. So that if you calculate the difference between them, it is nothing but delta by 2, which is less than delta. Now I am calculating the respective function values. So f of x1 minus f of x2, if I consider x1 square minus x2 square is equal to x1 minus x2 into x1 plus x2. So x1 minus x2 is nothing but delta by 2. And if you substitute the values here, it is 2x1 plus delta by 2. So the result is nothing but delta x1 plus delta square by 4. Accepted? The value. If you calculate mod f of x1 minus f of x2. Now what I am saying that this value is not less than epsilon for all x1 comma x2. Because if you want to say that that value is less than epsilon, so it is nothing but two positive numbers. One value is delta square by 4, another value is delta x1. If you want to say that this whole thing is less than epsilon, so you should confirm to say that delta square by 4 is less than epsilon and delta x1 is less than epsilon. Then only the sum has the possibility which could be less than epsilon. Agreed? Since delta is however small, delta square by 4 is always less than epsilon. But coming to delta x1 is less than epsilon for all x1 is not correct. Because in the whole real number system, x1, x2 are any two real numbers. If I take x1 is equal to 100, delta x1 will be less than epsilon. That should be a question. Say delta is equal to half, x1 is equal to 100. Then what could be delta x1? It will be 50. So is 50 less than epsilon? Because epsilon is arbitrary, very small number. Are you getting the idea? So it is not possible to say that even though x1 x2 difference is less than delta. Yes, because x1 x2 has no bound. You can take any values. It is possible to say. So the function is not uniformly continuous because the value will not be less than epsilon always. For some values it is true, for some values it is not true. Okay? Is the logic reached to everyone? Or you want an example with numbers? Please tell. If you want an example with numbers, let us go with some numbers. What is delta, what is epsilon? Take let us two numbers x1 and x2, which gives the idea. Is that required? Fine. Then let me take one interesting problem. I think it is also given in the previous year papers. I hope so. So you take that f from r plus to r defined by f of x is equal to sine 1 by x. F of x is equal to sine 1 by x. And I am saying that it is not uniformly continuous. This was the question. So you take the function f from r plus to r defined by f of x is equal to sine 1 by x. And we are going to prove that it is not uniformly continuous on r plus. Okay? Is the question task clear? Now I am going to choose the two numbers x1 and x2, and even though the difference between them is less than delta, but if we calculate the function values f of x1 and f of x2, it will not be less than epsilon. So for this also you take the same example, say epsilon is equal to 1 by 2. I am going to choose x1 and x2 as the values. So you take one value as x1 is equal to 1 by x2 is equal to m pi, because if you take the difference, it must be less than delta. And how the value of delta will be taken? You note down this result. Since it is beyond our scope, I am not going to discuss about this. Just remember the result. So what is the result? Whenever you take a delta, then always you can find a positive integer such that 1 by 2n into n pi plus pi by 2 is always less than delta for all n greater than or equal to m. You please take a note of it. I have taken the two numbers as one number is equal to x1 as 1 by m pi plus pi by 2, another number is equal to x2 as 1 by m pi. So you can observe that if you calculate the difference, it will be less than delta. Okay? How it will be less than delta? Let us calculate the value. Consider mod x1 minus x2 is equal to modulus of 1 by So as per the result is concerned, if you consider mod x1 minus x2, the value is less than delta, because the value is nothing but modulus of 1 by 2m into m pi plus pi by 2, and the result says that you are able to find a positive integer m such that that value is always less than delta. Now if we calculate the corresponding function values, f of x1 minus f of x2 is nothing but modulus of sine of, since f of x is given by sine 1 by x, if you substitute x1 as 1 by m pi plus pi by 2, it is nothing but sine m pi plus pi by 2 minus sine m pi. So this is nothing but modulus of cos m pi is equal to 1. Accepted the trigonometric part, because sine m pi is 0 and sine of m pi plus pi by 2 is nothing but cos m pi, just like sine of 90 plus theta. I hope so. So since cos m pi takes the values either plus 1 or minus 1, since the modulus is presented there, its value is always 1. Therefore you have taken epsilon is equal to 1 by 2. But even though you have taken two numbers whose gap is less than delta, the corresponding image value is greater than epsilon. Therefore, the function sin 1 by x is not uniformly continuous. So for this problem, this result is somewhat interesting, but it is not in our earlier discussion. It is beyond our scope. It is assumed that it is learned by you at your graduation level with regard to real analysis. We should understand like that. So please check the solution part. If you have any query, you can ask. Any query you have? Are you clear? There in the LCM part, you can see it will be minus pi by 2. Is the solution part clear, or you have any questions? So I just want to give one small example, then we can conclude our discussion. So you take that the function f of x is equal to 1 by x on open interval 0 comma 1. Now, since the interval is taken as open interval and the function is 1 by x, it is continuous there. You can calculate the limit part if you are interested, because f of x is not equal to 0, its value always will exist. Apart from saying that f of x will not tend to infinity, I can say you just take like that. Do you agree for that? So if you have doubt, if you take 0.0001, then apart from writing this, let us say that it is a continuous function on closed interval 0 comma 1. Will you accept for this? If you take f of x is equal to 1 by x on open interval 0 comma 1, right? Now let us verify the same uniform continuity criteria here by taking a simple example. So you simply say that if you take a delta value and take 2 points x1 and x2, and always we can say that there is some positive integer such that 1 by n is less than delta. You can take one value as 1 by n, another value as 1 by 2n. We can take like that the values as. So 1 by n is less than delta for all n greater than or equal to m. So you can take that one value as m, another value as 2m. So if you consider mod x1 minus x2, which will be less than delta, and if you consider f of x1 minus f of x2, So this is one simple example you can take. The function is continuous on the open interval 0, 1. If you check for uniform continuity for the function, it is not uniformly continuous, because if you take randomly epsilon is equal to 1 by 2, or you can take epsilon is equal to 1 also, you fix any delta greater than 0. Obviously for the given delta, always you can find a positive integer m such that 1 by n is always less than delta for all n greater than or equal to m. That you can see by taking some numbers. Now you take one value as 1 by m, another value as 1 by 2m, the 2 points. So if you consider the difference between them, it will be 1 by 2m, which is less than 1 by m, nothing but less than delta, I can say. So if you consider the function values f of x1 minus f of x2, then the value will be equivalent to m, which is greater than epsilon. So even though the difference between the numbers is less than delta, corresponding function values is becoming greater than epsilon, hence the function is not uniformly continuous. That was the thing. Okay? Is that clear? So this is one example you can consider, that if the function is continuous on the open interval, then it need not be uniformly continuous on that interval. So uniform continuity criteria is applicable only for closed intervals. So for the counter example, this you can take by taking an open interval there. So at this point of view, I want to conclude my discussion with regard to uniform continuity. So from the next session onwards, we will discuss a new topic, that is differentiability of the functions. What are the physical significance of uniform continuous? Right. For this, let us take a thing one. Have you noted this? Can I erase? You please take a note of it, then we discuss about the physical significance of uniform continuity. Right. So one assumption, you can say that if the function is uniformly continuous, if you draw the graph of the function, we can say the variation of slope is fixed. It is not always true, but if you think about the geometrical issue, you can say that for majority of the cases, if the function is uniformly continuous, so if you consider the graph of the function, the slope is varying with a fixed constant. But we are not aware of the value of E, then how can we say that M is greater than E? Right. Then we can just say like this. Now you give me a value of E here. What are the value you want to take? The epsilon value. 0.8, right? Actually, what is M here? I have written that for delta greater than 0, there exists a positive integer such that right. So you are taking M as an integer, right? So what is the smallest integer number you can take? 1. M is equal to 1, isn't it? So the minimum possibility for M is nothing but 1. Accepted? The minimum possibility for M. So 1 is greater than 0.8. That is satisfied? Right. So in other words, you are saying that for the function 1 by x, what you have taken, Suppose you have fixed delta is equal to say 1 by 4. So what are the values which are less than 1 by 4? We cannot take epsilon as greater than 1. I think the concept of epsilon delta is always giving confusion to everyone. I hope so. So right from the beginning of continuity, I am thinking that the concept of epsilon delta is giving confusion. Epsilon greater than 0 is arbitrarily very small positive real number. You cannot take usually 1, 2, 3, 4, so on. At the most, you can take it as 1. You can say epsilon is equal to error, in other words. That will be somewhat useful to understand. Fine. So you cannot take epsilon as greater than 1. So while doing the experiments, how much error we are allowing, you can take it as epsilon. If you say that the error is greater than 1, means you are allowing huge error. Will you agree for the practical situation? No. So you just take that epsilon is arbitrarily very small positive real number always. Always we fix that it is greater than 0 and at the most it is equal to 1. While doing the problems. Okay. So on the whole discussion of this continuity and uniform continuity for this chapter, with regard to delta and epsilon, what is your understanding, may I know from everyone? What you have understood? With regard to delta and epsilon. Okay, they are less than 1 and small. Fine. Let's take one type of discussion that gives an idea. So let us take like this. You take f of x is equal to step function of x. Is it a continuous function? No. Because it has many points of discontinuity. Right. Suppose you are saying that this is our whole discussion so far considered in the entire chapter, isn't it? Say difference between the values less than delta implies difference between the function values is less than epsilon, then it is continuous, otherwise discontinuous. Accepted? Yes or no? Suppose you take the values as, say delta is equal to 1. Let us fix that. You accepted for this? All of you? If we calculate f of x4 minus f of x2, which is greater than epsilon? Yes or no? So, you know that the function is discontinuous. Yes, if you take 2.5, 2.8, then you are correct. It is 0 less than epsilon. Now, please understand, you are checking the criteria that at every 2 points, whose gap is less than delta. You should be able to understand that. For every point, whose gap is less than delta. So, you are taking the positive values which are satisfying the criteria of less than epsilon. So, will you say that if you take 2.5 and 2.8, then the function is continuous? So, at which point can you say? From 2 to 3, the function is continuous. At 3, it is discontinuous, right? Yes or no? Because limit x tends to 3 minus, its value is equal to 2. Limit x tends to 3 plus, its value is equal to 3. Accepted? So literally, if you take a neighborhood at 3, the neighborhood what I have taken is 2.5, 3.4, the values with a gap of 1. So it is nothing but I have taken the neighborhood as 2 to 4. Usually we take a small neighborhood. For your convenience, I have taken this much of neighborhood. So in this neighborhood, I have taken 2 points. One point is 2.5, another point is 3.4. Literally, the gap is less than delta. It is satisfied. So you are saying that if I take any 2 points whose gap is less than delta, if the difference is less than epsilon, it is continuous. So it is possible for every point which is taken here such that the gap will be less than epsilon always in this thing. So at this point it is failing, even though the gap is less than delta. So if we take 2.5, 2.8, the difference is less than epsilon while considering the function values. But if you take 2.5, 3.4, then it is not satisfying. But practically, if you draw the graph, we know that the function is discontinuous at 3. Yes or no? Left limit, right limit are not coinciding. So in this way, the concept of delta and epsilon will be useful. So within the neighborhood, you take any 2 points whose value is less than delta, the corresponding values are less than epsilon. So even though if you allow that epsilon is greater than 1, say epsilon is equal to 2, then here you say that it is less than epsilon, so that the function is continuous at 3. Do you accept? As you have a small doubt that why don't you take epsilon as greater than 1? Let us say epsilon is equal to 2. So, yes, that's why on the closed interval, if you say that it is continuous, then it is always uniformly continuous. I got the result already. I have given that. If you have shown that the function is continuous on the closed interval, then automatically it becomes uniformly continuous on that closed interval. For the open interval, it is not true. Because take the example of 1 by x on open interval 0, 1. It is continuous but not uniformly continuous. Because occasionally you can find some elements the gap is less than delta, but function value is greater than epsilon. Okay. So any more clarity over this delta and epsilon? So can you say that by taking epsilon is equal to 2, the function is continuous at the point 3? Do you accept? Since the value is satisfying, can you say that the function is continuous at the point 3, the integer part function x? Yes or no? So always epsilon will be taken as arbitrarily very small positive real number. At the most we take it as 1. Maybe if you are doing some practical experiments, in that case you can take epsilon as greater than 1, but usually always it is very small real number lying between 0 and 1. Any other queries, please? Questions asked in UPSC is of fixed pattern regarding uniform continuity. That is the questions that we solve in the class. Fixed pattern in the sense you are asking the approach. Yes. Yes. The technique what we have applied here with regard to delta and epsilon, the same type of questions are asked in UPSC with regard to uniform continuity. I'll give the relevant postage of 2 to 3 questions. The solution part, you can read them and you can understand. And those questions are asked in the UPSC, previous year question papers, you can check. Right. The best part you can concentrate on this limits and continuity sequence criteria. So if you observe the previous year question patterns of UPSC, so earlier majority of the questions are asked on proving continuity, finding the values of A and B, and sequence criteria. So for the past 2 to 3 years, the questions are asked on uniform continuity, and at present only concentration is given on Riemann integrable functions, improper integrals, etc., etc. You can observe the previous year questions pattern. But these are some areas we need to concentrate. Just building relation between delta and epsilon. If you understand the lattice, that is sufficient. More than that is not required. Fine. Anything else to ask? So, is the concept suffice for you in getting the idea or this continuity and uniform continuity? Or you are still in confusion in getting the approach? Fine. Then let us wind up our session here.